Hello, this is question 14 on your June 2018 paper 1 from AQA. You have to use G 9.81, just be careful because usually we use 9.8 if they don't say anything. Two particles, mass 1.8 and 1.2, are connected by a light inextensible string over a smooth peg. Initially, the particles are held at rest 1.5 meters above horizontal ground, and the string is taut. The particles are released from rest. Find the time taken from this one to reach the ground. So when we release from rest, this one is heavier than this one, so it's going to move this way. Yeah, the pulley is moving that way. This one is moving this way with an acceleration, and this one is moving the same acceleration but up. If we draw the forces, we have 1.8 G down and tension up for this one, and the same tension up for this one, and 1.2 down. Yeah. We need to find the time taken. The minute dimension time, we need to use Subat equations. So if we write Subat equations for this one, we have Subat. Displacement that this one has to move is 1.5 until it reaches the ground. The initial velocity is 0. Final velocity we are not interested in. We need the acceleration, and the time is what they ask. Remember that we can find the acceleration using the forces. So if we write the equation of forces for this one, so remember I'm using always resultant force is mass acceleration. So for the first one, for the 1.8 kilo, I have resultant force is, as it's moving down, this one is greater than this one, so I'm going to write this one first. 1.8 G minus T, so that's the resultant force, is going to be the mass acceleration. And I'm going to write the same for this particle, but this particle is moving up. If it's moving up, this one is greater than this one, so I'm going to write this one first. Resultant force is T minus 1.2 G. And this is equal to mass acceleration. And now what I'm going to do is eliminate T because I'm not interested in T. So I'm going to add them. So I'm going to solve simultaneous equations. I have simultaneous equations with A and T, but I just need A, not T. So I can add them so these two are cancelled. And then I have 1.8 minus 1.2 G is 0.6 G, and 1.8 plus 1.2 is 3A, which means that the acceleration is 0.2 G. So I know this acceleration here is 0.2 G, and now I can use Subat. So I need a Subat equation without V, which is this one. S is ut plus 1/2 8 squared. S is 1.5. U is 0, and then I have 1/2 of acceleration times t squared. And from here, knowing that G is 9.81, we find that T is 1.3237 something. So I'm going to round to 3 significant figures. Do they ask me something? No. 3 to 4 seconds to 3 significant figures. Yeah, I get that negative value when I do the square root, but negative 10 doesn't make any sense. And then B state one assumption you have made in answering part A. Usually in these questions, when they ask you find the time taken for the 1.8 particle to reach the ground, they tell you as well that this one, assuming that this one doesn't hit the pulley first. So imagine this is less than 1.5, when before this one hits the ground, this one will hit the pulley and then the whole thing will stop. So this is one assumption that we've made that usually they tell us to make, but we have, because otherwise we don't know how to answer the question. Yeah. So mass 1.2 kilograms doesn't reach the pulley. We are assuming that. Because if it reaches the pulley, the whole thing will get kind of stuck. Yeah, and that's all with this question. It's quite a quick question.